And then welcome Nancy from Iowa State. Nancy is a big shot in the field of case studies. She actually is funded by NSF to help build more case studies. And so she's here today to talk to us about her work and how exciting and fun it is to work with case studies. Nancy, the floor is yours.
Oh, well, thank you so much for the warm welcome and introduction. Um, yes, I love teaching case studies. I'm going to share my screen here in a second, and I'm going to try to go through some of the background, and then we're going to get to work and build out some teaching case nubbins, as I like to call them. Like, if you have an idea, what can you potentially teach with that story? So we'll start, and then we'll get some work time in, and then go from there to what the next steps could potentially be. And that's kind of where we're at. So give me a second to figure out where the share button is that I just had a minute ago. Okay, did that work? Yes, no?
That looks great.
Okay, we've got it. So um, crafting context. The whole point of a teaching case study is contextualizing your STEM stuff. And I'm putting in a very general terms for stuff. For biological sciences, that's vision and change. For other disciplines, they have other curricular guidelines, but it all kind of connects. A lot of times people taking classes, how is this related to the real world? Building a teaching case study will get you that real world connection. So in an effort to model good teacherly scientific teaching behavior, the learning outcomes from this presentation, participants should be able to diagram the continuum of teaching case studies and kind of look at their complexity and use, identify where you might find some teaching case study ideas or stories in either the news, history, primary literature, you name it, and then how to connect some of that to the courses you're teaching, and then building and testing the case study, because if you want to publish it, a lot of different publication outlets would like to see that the thing you've built actually works to help students achieve your learning outcomes. And so we need some data to that effect as well. And I see some nods around the group. Okay, so first off, if we're going to be talking about teaching case studies, what is a teaching case study? Well, teaching case studies, which I abbreviate TCS, are a teaching modality or strategy that has an interesting narrative that generates some sort of empathy with characters that are involved in doing a thing. They run through a plot of some sort. There is a setting. It is a story. Okay. And the other piece to this, the teaching part of these case studies, is that this story leads to the achievement of student achievement of your defined student learning outcomes, which is kind of the point. It is a teaching modality. Usually these are somewhat of a complex problem, or maybe a situation that has a lot of connected ideas or complexity. We were mentioning just now about somebody doing deep diving for over 20 minutes. There's a lot of things that have to happen for that to happen. And you can teach about all of that different anatomy and physiology using that as the hook for your story. It is a structured inquiry. You have established measurable learning outcomes. You have listed out what the prereq knowledge is, because that then frames your teaching case study into where it might fit into whatever curriculum. Which course should this best go to? And then you should also, at some point, write up a teaching classroom management plan, but that's usually later. I know there are some that say that you should do it at the same time. I'm never that organized. Maybe I should be. The teaching case study is going to connect the students to the course content. It's going to connect the students to each other, and it's going to connect those students to the instructor, because, who doesn't like a good storyteller? And if you're telling those stories, you're making those connections and making it relevant. Case-based learning, in case you're wondering where this actually came from as a pedagogy, It was first documented in like 1910-ish at Harvard Business School, where they would set up business scenarios and then teach with those. And then it picked up along, Harvard did it first, and then a whole bunch of different business classrooms. Then it was picked up by law schools. Then it was picked up by medical schools, and then eventually STEM classrooms. And the STEM classrooms is like the last maybe 30 years. And it's been gaining steam as it goes, but we don't have hundreds of years in STEM doing case studies, but case studies as a teaching modality is over 100 years old. All right, so why we do teaching case studies? This is really our opportunity to analyze some data, maybe identify issues associated with something interesting that is part of your course content or your intended learning outcomes, either writ large for your entire course or just for a particular day. And then connect with prior knowledge. It just depends on how you're using them. Okay, so putting this in a very simple way, we're going to use storytelling to connect that course content to some sort of a setting, some sort of characters, and some sort of a plot. Sometimes the setting leads, sometimes the plot leads, and sometimes it's character driven. But for teaching case studies, it's if it's character driven, that character is probably going through a very hard time. We'll just say that. Psychologist, why? We have some science behind teaching case studies and storytelling in general. Using the functional MRI, which is an amazing machine that tells the people that are studying this which areas of the brain are active when they're experiencing things. As you're doing this, if you use the fMRI and blood tests, you can measure the impact of stories. This isn't teaching case studies, but stories themselves on those that hear them for the first time. And if we look at this, we can see that blood samples will have shown that you have increases in cortisol levels. That's usually associated with attention and stress. Also, increased levels of oxytocin, which is connection with others and empathy. The fMRI showed activation in the regions of the brain associated with empathy and understanding. And then the idea here behind this is that this theory of the mind, we're understanding what others are doing, and then these oxytocin areas making us feel empathy for the characters. And sometimes the characters are people, but I have seen and made a few case studies over the years where the characters you need to empathize with are molecules, which is, you have to warn people, no, we do not anthropomorphize things, but sometimes we do for teaching. Okay, so what do we mean by case studies? Well, there are case studies that are quite simple, these kind of least complex ones, and there are ones that are kind of complicated. The complicated ones tend to be primary literature. They may be debate case studies where you have equal evidence on both sides of an issue, or maybe multifaceted, so it's not just one versus the other, like a dilemma case study, but maybe 3 or 4 different perspectives. And they kind of have this continuum of use. They're all useful, but they bring different things to the table. If you just want people to kind of be familiar with something, you could do a class opener that's basically the news. And this morning, I was teaching medical microbiology, and I was like, oh yeah, there was Legionella in New York, and we had just talked about Legionella earlier in the week, and there was like a 10-minute conversation that I had to shut down because people were kind of excited about the fact that Legionella was in New York. Kind of gruesome, but true. And then there's the understanding and comprehension. We have this idea of interrupted case studies where you control, as the instructor, you control the narrative and you control what you're telling, how much you're telling, and you can have like a question response. So you can tell, you have a certain amount of exposition or story, and then you ask a bunch of questions. Clicker questions are amazing for this. And then you gather the data, and then you give them another piece of information or another chunk of exposition, and then you ask more. And so interrupted case studies for large classrooms, those are absolutely amazing to hit that balance between teaching and laying out a bunch of content and also getting that interaction and active learning, because you're stopping the process, every probably 5 or 10 minutes. Dilemma case studies, where you usually have like, should your main character that you have developed empathy with choose path A or path B, and why? And if you make them complicated enough, about half your class will go either option, and then they have to defend their perspective. So this can be in class usually. And then the last one, these problem-based or journal articles or debate, these typically are more than one 50-minute class period, and they can be homework, they can be take-home exams, you can pick up threads of this one long-lasting case throughout a semester. Typically, however, when I'm doing teaching case studies that I just want to build a new case for a particular course, what I will do is have um, the middle ground here. So our understanding comprehension, either an interrupted or a dilemma case study, and it's really designed to be delivered in a 50-minute period, because that's the course I teach. Those are the courses I teach. And usually with clicker questions, because I'm in a large R1 institution, I typically have fairly large classes. I want to build these cases so that everybody could use them, even if they teach very large classes. And if they teach smaller classes, you can adapt to some of it's easier to adapt a case study written for a large class to a small class than the opposite. Because if it was written for a small class, you have to make a lot of changes to be able to deploy it in a larger classroom. So things you consider. The first thing is, what's your intent? Why are you doing this? A lot of times when I build a teaching case study, it might be the review, like the unit review for a particular thing. If I can find one that connects a lot of things that we just talked about, that's amazing. Or sometimes it'll be something where I just want to introduce it, and this is my hook into a new unit. Like if I'm teaching metabolism, I'll go find something interesting about fermentation and bring that in. Okay. The other thing is there any ancillary skills? And if so, what are they that you want to teach through this? Do you want to assign some sort of a technical communication artifact to the students, where they have to produce an infographic, or they have to communicate with their peers in a particular way? Do you just want to highlight the fact that there are job opportunities that students may or may not have ever heard of? I teach a One Health class, and a lot of the case studies that I use there, some of the things I'm highlighting are, there are um, infectious disease ecologists that are out there studying the movement of infectious diseases through animal populations. And, this is something that a lot of times students had never even heard of. Social issues that might be associated with a particular thing. Is the treatment that was proposed, is it a genetically altered something or other? Or is there molecular biology techniques involved? Those tend to be hot button issues. Vaccination also seems to be a hot button issue lately. Evolution. Can you pull any of that into it? And do you want to? Was it intentionally, are you going to do that, or are you not going to do that? And you need to kind of keep that in mind. Can I throw some data at the students and have them do some data analysis? How to read a figure, how to interpret data and draw conclusions. And that's the scientific reasoning piece. How are you going to use this case study? Is it going to be a one and done in the classroom? Where everything's given in class? Is this going to be homework? Could I make this teaching case study and give it as an exam? It's an option. Okay, so where do you get stories? Well, my go-to is I have about a 40-ish minute commute. I tend to listen to podcasts on my way into work. I kind of have a playlist here. I also like to look at certain websites just for science stories. Eureka Alert, Science Daily, Live Science. Atlas Obscura gives you some really good, obscure, as its name would indicate, stories. I also like books, particularly ones that are compilations. Things like the Best American Science and Nature anthologies, those are every year. The Disappearing Spoon, or anything by Sam Keen. There are other authors like Mary Roach. If she writes anything, I will look it over. Dr. Zhou in What You Don't Know and all of his chemistry books. He has an amazing number of chemistry stories. It was one of those books where I learned that a goodly portion or proportion of the vanilla we have in vanilla ice cream and the vanilla that is used commercially comes from sawdust because it is chemically modified from lignin in sawdust. It doesn't come from vanilla, like the plant vanilla. So I'm still figuring out how I'm going to use that in a case study, but I will. So let's get started. I've talked for like 15, 20 minutes. Let's not be me talking. I'm going to give a couple of examples as to case studies that have either already been built or there's one that's kind of in process. And then I'm going to, we're going to set up some breakout rooms for people to talk about. So this is a case study that's been published. We did this a couple of years ago. So the emergence of VRSA-1 or vancomycin resistant Staph aureus in the United States. And this was a documented case. It was a New England Journal of Medicine article. It was like a 3-page article that said, hey, VRSA happened. It's the story of a woman in Detroit. She had diabetes. She had failing kidneys. She was on dialysis. She had multiple infections over 2 years, and she had progressive surgeries to remove the infected areas of her feet. And for this particular case study, I actually showed pictures of what that would look like with some warnings of you don't show those type of pictures without warnings. Otherwise, students might end up throwing up in your class because those are not great pictures. And she started off with MRSA or methicillin resistant staph. And after 2 years of lots and lots and lots of antibiotics, and I showed a figure that was all the antibiotics this woman had had for 2 years, she had vancomycin resistant staph. So what do you think the concepts would be that I could use? What could I teach with this story, this layout? And just throw them in the chat, or if anybody wants to speak up, I'm good with that too. And I'm trying to find where the chat is on this. Okay, got it. Okay, antibiotic resistance, diabetes physiology, protein structure, evolution, nosocomial, how staph works, bacterial evolution, immune system in chronic disease. All right, I'm seeing a lot of things. All right, I'm going to move the chat over a little bit and go to the next thing. This is kind of you start with the brainstorm, and that's kind of what we just did here. And this was when I was given this story by a colleague and he wanted to build a teaching case study with it. This was what the two of us actually came up with is, antibiotics. What does a gram-positive cell look like? Because this is staph. The genetics of horizontal gene transfer, the VRSA gene, like the VRSA operon, or the vancomycin resistance operon, just to be precise in the terminology here, is not only is it an operon, but it's also on a transposon. It's the one that they found was on like a transposon structure. And then antibiotics resistance mechanism, the mechanism to resist methicillin is very different than the mechanism to resist vancomycin. So we talked about cell structure function and how you build a gram-positive cell wall and how methicillin messes that up, but vancomycin does as well, but in a different way. And then the disease triangle, the host, pathogen, and environment. What host factors made this emergence more likely or versus less likely? What pathogen, what about the pathogen made that more likely? What about the environment made that more likely? If any time I can lean into the disease triangle as a microbiologist, I am there. And so at the end of the day, we built the case, we tested it in classes, and we published it as a teaching case study. If anybody wants to use this, it's published and the notes and all the things are there. It is in JIMB as a curriculum paper in 2022. So the second example, this one is not published. I still need to write the notes. It's done, it's been tested. I just haven't written the notes yet. So there was a story of a patient that was affected by Pseudomonas contaminated eye drops. The story, I'll give a little more info on the story here in a minute, but because we have a patient with Pseudomonas in eye drops, we can talk about eye anatomy and physiology and the fact that eyes are a privileged site. Why is it important that your cornea doesn't scar that often? And why is that relevant when we have an infection? We can talk about quorum sensing, Pseudomonas quorum senses a lot. We can talk about antibiotics and resistance. We can talk about that disease triangle again. We can talk about Pseudomonas as a gram-negative bacteria. How is that different than the gram-positive bacteria? And we can talk about genetics and epidemiology. How do you track? Because this was contaminated eye drops that were contaminated in the factory, how did they know that? Well, from genetic testing. So we found, because we knew that this outbreak happened, we found a single case with a woman in her 70s that had survived cancer. The chemotherapy had left her with dry eyes. She had trigeminal nerve damage. That gives us an opportunity to talk about some of that as well. Gave her a name. Her name, like name changed for these purposes, but we gave her the name Phoebe. We summarized her clinical journey through the testing, through the treatment, and her recovery. But as we were doing that, we gave the student each at various time points throughout this journey the pathogen identification. So just identifying what the differential diagnosis was, what the doctors thought it might be, what tests they ran, how they did that. And then we also gave the antibiotogram with the breakpoints for common antibiotics and asked them to choose treatment. And it was kind of a trick question because the antibiotogram showed that nothing that they had would work. Phoebe was treated with a new hybrid antibiotic that actually has a super interesting mechanism of action. And then we had exposition of how this new antibiotic worked. It was a siderophore that is it was a combo antibiotic that was part siderophore. So grabs a piece of iron, gets into the cell like a Trojan horse saying, I'm just a piece of iron, gets through the outer membrane of this gram-negative cell, drops off the iron, drops off the siderophore part, and now we have a cephalosporin in there with the peptidoglycan wreaking havoc with the cell. And it actually works against this bacteria. But it's a relatively new antibiotic, and it's really got an interesting mechanism of action. And the really nice thing as a microbiology person, whenever you talk about cell structure function and you do boring things like how the cell gets iron, the students' eyes tend to roll and like, ugh, why do I need to know this? Hey, here we go. This is why you need to know it, because this antibiotic works this way. This is, anyway. And then this whole thing is one 50-minute class period, multiple formative assessment, clicker questions, and discussion points throughout the whole thing. So that was my two examples. Your turn. Let's take 5 to 10 minutes. I was estimating about 7 minutes in breakout rooms, and identify an interesting story that you might be able to link up to 5 things to it, like we did there. That's the first step in building a new teaching case study. What cool things could I link to this interesting story? All right.
Oh, good. Breakout rooms were opened.
Well, hello, folks. As you get back, I'm sorry I didn't quite know how to do Zoom breakout, like how to stop the breakout rooms. So I'm glad everybody came back. I'm going to reshare my screen. go back to share screen mode so I know what I'm doing. And so we just kind of finished this part. And now my question for everybody is, what stories did you come up with? Either in the chat, or if anybody wants to unmute and talk about it, this time and place.
Heather brought up a most intriguing story about someone she knew who did a DIY fecal transplant. And we're not going to go all that way there, but basically the guy was injured, ended up with a C. diff infection, wanted to, well, solve the problem by replacing his microbiota or getting rid of that one. So we thought some of the potential concepts. We only had 4 concepts we nailed here, but something about the microbiota, something about the effects of antibiotics and their uses, something about fecal transplants, of course, and maybe the effects of diet.
I think all of that is amazing.
Others have ideas.
So I think that you got a great start. Could, hit the ground running on that. Other ideas? Got rabies, the world, rabies is amazing. There's all sorts of things. Oh, there are reports that they think Edgar Allan Poe died of rabies. We're not, that's not 100% certain though. Other ideas?
In our room, someone suggested a story that some of their students had found once about a form of mycobacterium that's called M. bovis, which normally infects like cattle and large animals and not humans, but can cross infect. And it turned out that the people had acquired it from a zoo. And so we had connected that to a lot of immunology, lung physiology, antibiotics, types of bacteria. But then I was Googling this as well, and it turned out that people can also get that from drinking unpasteurized milk, which is also a thing that's sort of currently in the news. So it could kind of connect a lot of different ways to public health.
I love everything you just added. There are reports, I'm trying to remember, M. bovis is probably one of the closest relatives to Mycobacterium tuberculosis, and there is some reports in the literature that we got TB into the human population because we started raising cattle. I don't know how strong the evidence is, but I do know there are a few reports out there. So I'm not sure if it's true or not, but it is interesting. But yeah, that's amazing.
I'm the person whose group, that was my group, and those are my former students, and they got that as a presentation they had to do for my bacterial pathogenesis class, and they had to pull a CDC morbidity and mortality weekly report. So that was the original source of that. So that's a wealth of wonderful, uncommon situations that could be good case studies.
Yeah, I absolutely forgot about MMR, morbidity mortality weekly report. There was a case of histoplasmosis in travelers. Was it histo? I think it was histo. In the last 6 months or so that I was looking, I've been eyeing it sideways going, ooh, fungus. But yes. Any other ideas?
I wonder if anyone had non-medical, non-microbe cases. Oh, sorry, Brenda raised her hand.
Yeah, well, I was going to just share that in our group, Shubha talked about a chemistry case study that that she is working on, and she put the link to it in the chat. But it's about a man that asked ChatGPT about how to cut salt from his diet, and he ended up substituting sodium chloride with sodium bromide, ended up with like psychosis, and was hospitalized for hallucinations and stuff. So that is a very interesting news story that she mentioned.
I think that's amazing.
We actually had a non-medical in our group too. Christina brought up using anglerfish because she talked about how she had looked up anglerfish when they mate. The female's larger, the male is smaller, and when they mate, the male literally fuses with the female and remains that way. And the immune system doesn't attack him, and she was talking about how it would be a great idea to build into, and this is for freshman biology, but build in more about the MHAC proteins and there's a bunch of different ways that you can go through that, like cellular processes. We talked about immune systems and phagocytosis, lysosomes. So there's all kinds of different directions that you can take them with that.
Amazing. And yeah, I hadn't really thought of like the tissue rejection part of that. But yeah.
Yeah, I thought that was pretty cool what she
Yeah.
had thought of.
Oh, any other cases, thoughts? I do have a, oh, we have hormone secretion and neuro, antidepressants and the gut-brain axis. Amazing. And how SSRIs work and how all the things. That would connect a lot of different physiology, microbiology, chemistry. So, you know, anytime you can take a thing that is kind of a here and now and some sort of a circumstance that the students can relate to, and then teach the story behind it. One of the things I do, like the first day in my general micro class, my 300 level, like micro for majors class, is the microbiology of a Snickers bar. There is a lot of microbiology that gets you that Snickers bar. Think about all of the fungus that had to ferment the chocolate. Think about how expensive the nougat is because the eggs are expensive because of bird flu. Think about the fact that there's peanuts, and peanuts came from legumes, and peanuts have a lot of protein in them because they get a lot of nitrogen because they're legumes. So that's just, I mean, there's lots and lots of things where as long as you can get a thing that is concrete that students can relate to, whether that be a main character in your story or that is, you know, a thing that they interact with every day. I've just heard in the last week or so, there was one of the energy drinks just had a massive recall. It's, I don't remember the brand name, but they had a massive recall because their stuff was mispackaged and the energy drinks went out to the public with like a significant amount of vodka in them. So now I can talk about alcohol. So, and I can talk about what energy drinks do, and I can all those things. Jack, you have your hand up. Sorry, I'm not really good with Zoom. I'm sorry.
Oh, no, I just, because all of the examples have been biological or medical, I just have to have one that is not. This is a Blu-ray player. And during the pandemic that I got, just happened to pick up in the surplus equipment recycling and computer science during the pandemic because I like fixing things. And when I brought it home, it boots up and crashes. And so I Googled to figure out why it was doing this weird behavior. And it turns out that Samsung Blu-ray players connected to the internet retrieved an empty file, which was supposed to be a list of the players that weren't supposed to talk to the internet on June 19, 2020. And anyone that did that immediately saved that file in its memory and was not able to boot up again. And so this is in a class of discrete math for computer science, where we talk about the importance of using mathematical notation of proof, of testing, and all of these sort of concepts for maintaining systems that talk to the internet, and the danger of those sort of things.
I absolutely love that. All right. Well, we are pushing to the end of nearly the end of our time, so I'm going to kind of push on for some of the next steps. So if you've done the process of getting a story and things that you could be connected to it, you have this nascent case study, aka a case stub or case nubbin, so to speak. Now what? Well, the first thing you got to do is get some more information, because this takes a fair amount of literature review. What I usually do is find, 3 to 4 primary papers. This is really important, particularly if you want data analysis as part of the story you're going to tell or the learning objectives you want the students to have. It's also particularly important if it's a topic you don't know a whole lot about. Get some review articles, because you want to know not just the stuff, but the nuances of the stuff. And then I also, if it's something that like has hit the news, I want to go find those popular press articles, because a lot of times the journalists will have done the hook part for me, like the interesting thing that I can tell the students, because that's what as long as it's accurate, it's amazing. And then you set the student learning objectives and the assessments kind of at the same time. You want them measurable. You want them to be a mix of higher and lower thinking skills. You want to build your formative and summative assessments kind of at the same time as you're building this out. And then build in the narrative where, who's going to be your main character? What's your setting? What's your plot? Is it going to be plot driven where it's a mystery to be solved? Is it going to be character driven where you emotionally invest in the success of this character and you want them to succeed at whatever it is you're doing? Or is it a mix of the both? Is it a mix of both? Either one is fine. Once you have your draft case study, you should go take it to a class and test it out. The way I usually do this, it's fairly formulaic, but you make a pre-post assessment based on the learning objectives. And then I usually do an affect question here and there. And so the pre-post data for the Pseudomonas eyedropper story, the title of that one is Dry Eyes Gone Awry, or Phoebe's Bad Morning. The learning objectives for that one were describe how the host pathogen and environment work, interpret how MIC works, explain the mechanism of this new antibiotic and how it could be used to treat extremely drug-resistant Pseudomonas, because I want them to know about that site iridophore. So the pre-test, and these were all 5 questions each. The pre-test, they're sitting at about 50 to 60%. The post-test, they're looking 80 to 75%. And then I calculated normalized learning gains, which is the proportion of what they could have learned that they did learn. And the benchmarks for an active learning class, anything under 30 is usually a straight up lecture at like 30% for normalized learning class or learning gains. And then anything over 30 is considered, 30 to 50 is considered, your average active learning class. And anything over 50 is, you're kind of hitting that really high point. And so I was very, very happy that the total score was 54%. I'm like, there was dancing in the streets. Yay. And this was like 55 students pre and post data. And I did it with a paired tests, like I did do significance on all of these and the difference, and they're all like 0.001 or something like that. So it worked. Yay. Okay, the other thing I do is an affect test, or affect, this teaching case study improved my understanding, or I feel like I've learned more, or I feel more engaged. I try to do a couple of those, and here I just took the jump printout and it's like strongly agree to disagree. And that's kind of it. And once I have that, and I've written up my teaching notes, which I haven't done yet, I'm going to take it to a publication outlet. There is the National Center for Case Study Teaching in Science. It is part of NASTA now. This was what used to be the SUNY Buffalo site. Course Source is another option, and they have more than just biology courses. They have biology, physics, and chemistry, and some other stuff as well. JIMBY, Journal of microbiology and biology education. You can also do content specific. This is, NIST is not biology centric, so to speak. You could do lots of different journals. There is a chemistry education journal. There's physics education journals. There are also journals. I have a debate case study that I'm going to be testing out in about a month. Yeah, in about a month, that I'm probably going to send to a One Health journal, because it's the case is about a One Health topic. It's basically students debating what the cause of an ancient disease was and the data that they used to debate it. And so it kind of fits with a One Health perspective. And I'm going to send it, even though the One Health journal isn't an education journal, I'm going to do it as, if you're going to teach it, here it is. And so you can send case studies that way too. And take home message, as I want to be respectful of everybody's time. The whole point of a teaching case study is to connect real world or clearly ridiculously fictional. Do not make a fictional story that seems real, because the students will get invested in the characters, and then they'll ask what happened to them in the end. And when you say they're fictitious, they will feel betrayed. So clearly fictitious, we're talking about molecules, or we put somebody on an asteroid or whatever, that's fine, because they know it's fictitious, or an actual real story. And then cases can be as simple as that news article you bring in, or they could be a semester-long quest. I actually have a colleague that built the case study around General Micro, and the first thing she did was crash the space shuttle onto an asteroid, and I was on the space shuttle, and she broke my leg within 10 minutes of the first class. And then the students had to go through and learn a bunch of micro to save the people that were on the thing. So it was fun. And then the first step really to do any of this, if you want to do this, is connecting an interesting story to that course content that you really want to teach, because this should be a method in which you teach the content you were supposed to be teaching, because all of us have courses with learning goals and learning intended student learning outcomes. This should be the way we can teach some of those, not in addition to, but as a way of doing that. So connect it to the course content, then research the topic, build out those measurable student learning outcomes, and then build it out. And on that happy note, I'm going to stop sharing and wave to everybody and take any questions and answers, but we have like 2 minutes, and I want to be respectful of everybody's time. Looking at the...
So I had asked in the chat how you use AI. I could imagine it would be useful in the brainstorming part for the students. And teaching proper use of AI could be one of the secondary goals.
Oh, no, I would definitely do something along those lines. I haven't used AI in building these, but I have used AI in finding some stories. Like, give me a story about fill in the blank. But I haven't then built, because that will give me the reference, and then I have a paper that I can read or a news article I can read. Maybe I'm just too much of a biologist that I don't trust AI not to hallucinate and give me things that aren't real. So I want to see the actual paper.
Yeah, and I agree that sodium bromide was a scary case study.
I'm just like, wow, wow. Well, congratulations, you got rid of sodium chloride out of your diet. They're not wrong. So